Hi there. In this episode of the Razorback screencast, we're going to be looking at the navigation system for the machine one more time. Maybe look at some of the cameras that it uses to avoid obstacles, and then we're going to start to look at the armor. I wanted to finish off the cameras before the armor because that'll make it easier to design armor around the areas where the machine needs to see. But before we get started on any of that, I'd like to make the flywheel housing a bit bigger. It seems like in the early stages of design here, the size of the flywheel housing sort of was determined, but I'm looking at it now and I think we can get away with making it just a bit bigger if we scale from this point down here. So the easiest way to do that is to reveal the flywheel housing, group it, and then move the origin of that group down to this point right here. Then we can simply scale the device up from that point like that. So now the flywheel housing looks a lot larger, a bit more menacing, and that's good. I will have to reduce its width a little bit because we scaled it up proportionally and its width changed. And we've got some batteries here at the side that we can't really move that much. So this is the new flywheel housing. Maybe I can adjust this bevel. There's going to be a lot of stuff done to that. The book talks about the flywheel housing and how it's covered in runes and sort of symbolic images, sort of spells and stuff, inspired by the creator's interest in Dungeons and Dragons, no doubt. So for this navigation camera, I am pretty inspired by everyone's favorite robot, Mars Curiosity. So the Mars Curiosity robot has these cameras up on masts and booms, that's fine. But then they've got these Hazcams. So these are used for navigation and, for looking at the ground. And there's some in front and rear. These are what the ones in the front look like, I believe. Although, these could be the rear. We see some tracks here going in circles, so this may have been when they were testing the turning of the machine. So I'm not actually sure if this is the front or the rear of the machine. Maybe someone who knows a bit better can help me out with that. But either way, I thought that these are an interesting design, and maybe we can have similar cameras, maybe a pair on either side of the Razorback that pivot slightly looking up and down. So let's get started on those. So I'm guessing those are going to be maybe 8 inches by 3 or 4. So we just start with a cube. And let's do an X dimension of 8. A Y dimension of 3.5, and a Z dimension of 3.5. So we get sort of a square cuboid. We can then go from the top view and move this to where it could live. I'm looking at this and it might be a bit too big, but that's okay. That's what we excel at doing in 3D, is making things too big at first and then making them smaller. So let's see. First thing we do is position them where we think they might go. So right about there. And then we test the steering. Is it going to get in the way? And the answer looks like a preliminary no. It won't get in the way. So assuming that these are our Hazcams, we're going to want some sort of a housing for them. So let's imagine this is the housing. In fabrication, I'm guessing the edges of the housing might be rounded. They're going to house a pair of camera lenses after all, so it would make sense to round the edges so that everything fits a little bit more snugly. And they may have a rounded rear side so that it can pivot more comfortably. So let's go ahead and just create that. We're just going to convert to editable polygons, so we can now sort of manipulate our cube. And I'm going to start off by rounding both the edges and the rear. So using the ring selection tool, we can select all 4 edges around the sides, and then using the loop selection tool, we can hold shift and select the rear face. So we have all of these faces now, and if we use the bevel tool, we should be able to create a nice beveled look. Now this bevel is really messy, and that's to be expected, but let's see what we can do about that. What if we took a different approach? What if we use the ring selection tool to just do a really gentle bevel? So something like, well, I'm trying to think of what would look good. Would it look good with a slight sharp edge like that, or would it look better with a larger edge? I'm just not sure. Let's leave it like that for now. And then we may be able to come to the back and bevel it separately. That does look a lot better. But we are limited in what we can do. So let's just leave it like that for now. What we can actually do is we can come to the side view and we can sort of change its construction from here. So let's focus on that a little bit. First thing we do is remove the n-gons where we feel comfortable doing so. This loop is a good candidate, as is this. So I'm going to select those. And then we can say UE to remove them. Now we can select this face right here, and we can start to scale it down. And we can follow it up by selecting these loops of edges and scaling them appropriately. Now once we've got an idea of how we want it to round out, we can just start to do that manually from the side. So we can say, okay, let's try to select these edges, and we can move this one forward. Notice I'm using the axis handle, so I'm moving it along its axis. And we can grab the second one, move him forward as well, scale him down, and we can select this guy back here, scale him down as well. I'm going to select this face in the center, and I'm going to use one of my favorite tools, the brush tool, in smooth mode, and we're just going to smooth it out. So just sort of gives us some more smooth transition there, and we can even pull it back a little bit and then smooth it some more. So that looks pretty good. I mean, for a start. Geometry back here doesn't look great, I have to admit. Maybe we don't use the brush tool. Maybe that was too ambitious. Instead, we can come in there and triangulate it a lot better later on. So now that we have this pod, we can consider putting a couple of camera lenses in it. Before we do that, I do want to reduce its size. It feels like it's a bit too big, so I'm just going to scale it down arbitrarily until I like how big it is. So I think that looks like a good positioning and everything. We can check it for clearance again. So it looks like it's not getting in the way. That's good. So now we can actually hollow it out quite easily by just selecting this front face, doing an extrude inner to the thickness we want. We can even measure that thickness. So if we wanted 1/4 of an inch, we could type 0.25. But if we wanted 1/8 of an inch, it'll be 0.125. And you can actually type in fractions here. This is kind of cool. So if you want 7/8 of an inch, you can actually just type 7 divided by 8, and it gives you that. 1/8 of an inch, 1 divided by 8. And you get your 1/8 of an inch wall. So then we can go to wireframe mode, and in R13 you can just control click and drag to create that new geometry. And we're just gonna pull it in a little bit until about there. That's good. And now let's throw a couple camera lenses in there. So easiest way to do this is just to create a couple cylinders for now, and then we can revisit the actual lens shape of each one. Alternatively, we could just copy one of these that we have here. Let's actually do that, since we've already created this. So we have two lenses here. Let's take the small one, Control C. I'm going to select this and then hit Control V. My preference is to paste the object in the hierarchy after what I have selected. So we can then select this lens's object and transfer it to the cube, position, rotation, scale, and it moves it right to where we need it. So now we can start scaling it down and moving it around. So we'd probably want it to completely fill the space, maybe with a slight gap around the edges so we see some nice shading. And then we'd want a pair of them. And they're going to be the exact same, so this might be a good opportunity to use a symmetry object. So I can just hold the Alt key, or I guess that would be Command or Option on the Mac, I'm not sure. And we can select a symmetry object. And what it does is it creates a symmetry object at that exact location, putting this object as its child, at which point we can just spread it out and it becomes a pair of lenses. And no, these lenses don't have to be right together, they don't have to be very far apart, but if we position them carefully, we can put some interesting details in there, like wiring and such. But for now, we can just leave them like that. And we can also decide to select this cube's face back here and say, okay, can we bring that forward? How do we want that to look for now? I think that's fine. So now we have this pair of lenses right there. Looks pretty good. And so this cube can now be called Hazcam. And we can just put this symmetry object with these lenses inside of it. Now this Hazcam itself needs to be replicated on the other side, and it should be part of the instruments group, so we can just put it in the instruments as Hazcam. Now because we may want to rotate the Hazcams independently, even statically, we may want to have this one pointing down a little bit and its guy on the other side pointing up a little bit, just for some variation. This should be two separate objects, but since the cam on the other side is going to be the exact same as this one, perhaps we should just use an instance. So we have a Hazcam right here. I'm actually going to group it again since I love null objects, and I'm going to call this Hazcam Null. And we're going to make the instance of Hazcam Null. The reason I'm doing it that way is because we transfer the hierarchy, and then we can add and remove objects below the hierarchy as much as we want without affecting our other instance. I'll show you an example. So all we do here is we say create instance. It creates another instance at the exact spot. We can just put it over here, and then we can move it to the other side. Now what's the easiest way to mirror an instance to the other side? Well, I'm not sure of the absolute easiest way, but in a typical case where the hierarchy is predictable like this, I usually just reverse the coordinates. So if its current H rotation is -15, well, we make the instance's rotation 15. If its current X position is 7, we make the X position -7, and it just transfers it to the other side. So now that we have these lower lenses, these Hazcams, we can actually say, okay, the null never really changes position from here on out. It can change rotation, so we can aim this Hazcam down a little bit, and we can even point this Hazcam further out, and they sort of become these individual instruments. Just for a little bit of variation, I'm going to tilt the other Hazcam instance down a little bit, not quite as much. So we do have variation here, but the great thing is that I can completely swap the geometry around, because Hazcam is now a child of Hazcam Null. So that means that if I were to, let's say I were to create some extra geometry, it's okay. Because let's say I wasn't happy with this housing, I can just delete the housing. And we still have the lenses, because the housing is simply now a component of the instance, which is pretty nice. So we have our Hazcam, and the next step is that we probably want a bracket that holds the Hazcam in place. Now, since the Hazcams are going to have the ability to tilt up and down, the bracket should be one that sort of goes over it and allows it to tilt as such. Reference material from RC helicopters that hold cameras are sort of my inspiration there. Let me see if I can pull up an image really quickly of one of those. Okay, here's a good example of an RC helicopter camera mount. So it's mounted to the underside of the helicopter right here, and then it's got this sort of articulating boom, and then it has this U-shaped mount where the camera actually is cradled, and then you have servo motors on the side that you can use to adjust it. This is really good. This is what we want, just something really simple that holds our Hazcam. So all we do is we just take a cube and we just model it so that it's got this arch over it. So let's go ahead and do that. To start off, we're just going to take a cube object, scale it down so it's manageable, and we're going to transfer it to the Hazcam Null. So it's right there. Now it's pitched forward. It's not really what we want, but we can just remove the pitch rotation from it. Now it's not pitched forward. It doesn't get simpler than that. So we probably want to make this out of aluminum or steel. Probably it's going to be the same width as the Hazcam bracket, roughly. And we're going to start with that. In terms of the other dimensions, I'm not really sure what they should be, so I'm going to work backwards. I do this sometimes. So we make it kind of how big we think it should be, and then we round the dimensions to sort of industry standards, or at least try. So here we have a cube that looks like it should be about the right size, and its X is 7.154, so we can easily make that 8 inches. Or, yeah, leave it at 7. Its Y is 0.236, so that's almost a 1/4 inch, but not quite. We could probably make it 1/8 of an inch, so, you know, we just type 1/8. Now it's 1/8 of an inch thick. And its Z, its width, its depth is 1.086 inches. So I think to round that up, we can probably say 1 plus 1/8 for 1 1/8. So it's basically now 1 1/8 inch by 1/8 of an inch by 7 inches, which is our arbitrary dimension. That's the width of our Hazcam. So now that we have that, we can actually just convert it to an editable object, and we select the face at either end. So we have those two faces selected. And we know that it's 1/8 of an inch thick, so to get a nice corner coming down here, we can just extrude it by another 1/8 of an inch. So if we extrude it by 1/8 of an inch, we get a square at the end here, because we're extruding it by the same amount that is its thickness. So we can then select these two faces down here, and we just do a control drag to bring the bracket down to the sides. So now that we have the bracket down to the level we want it at, we can just round the corners off as they would be. I guess they wouldn't need to be rounded off, but it would make maintenance and humans interacting with it a little bit better. To the viewer of the project, it also sells the idea that that's a pivot, because pivoted brackets are usually rounded. So right here we still have 2 subdivisions. That should be fine, and we can just round the end out. Looks good. And we can then, just for a little bit of flavor, we can just select these 2 edges right here up at the top that we have, and we can round those as well. Whoop, I just moved it. So you select our bevel tool. That's too many edges, so we just change it to 1 subdivision. That might still be too many. 0 subdivisions. I think I'm happy with 0. We don't really need a lot of resolution right there. It's a really small detail. So now that we have this bracket that holds the Hazcam, it's very convincing that we could pivot this Hazcam right here, and it makes sense that it's mounted in that manner. The part that's kind of weird now, though, is that these are just floating in space, so we need a bracket for them. And the easiest way would be to have a hard bracket that basically bolts to this component somehow and then bolts up onto the frame while avoiding the steering. So I think that's probably our next challenge. And we've done something like this before, right here, with the bracket for the steering mount. So let's do our best to try to create something similar. I'm just going to start with a cube. and I'm going to position it sort of on the inside of the frame where we're going to be working. And let's start off again with some standard dimensions. So let's make the X size 4 inches, the Y size 4 inches, and the Z size 1/4 of an inch. So we have 1/4 of an inch plating that we're going to create something here from. So if we can figure out where it would mount, maybe it would mount on the outside of the frame. So step 1 would be to figure out where it can go, where it can start. So if it were narrower, we could put it up on the frame like this. Just take a look really close. And it could be bolted to the frame. And then it could maybe come down behind this steering arm and mount our camera that way. So we have this plate here. It's intersecting a little bit. That's okay. Let me just bring it down to the edge. So our plate mounts right there, and that could be our mounting bracket for the Hazcam. And I'm thinking that what we should do is just bring it down, rotate it a little bit so it lines up with this bracket, and then just swing it underneath so that it can bolt on. We may want to reinforce this mounting somehow, maybe connect them to each other. That would be a good method of reinforcing them. Or maybe even have a secondary bracket come up here and curl onto the frame. I actually like that. That would give it a really integrated look, so let's do that. So the first thing I'll do is convert this to an editable object and duplicate it. We can always join it later if we needed to. And so now that it's duplicated, I'm going to bring it around to the side, and we can put our bracket right there. So this would be the secondary mounting point for it, and just for style I'm going to angle it forward a little bit. And it's probably okay if this one mounts up here on the higher edge of the frame that's sort of angled in. So we can scale it down. Well, we don't want to scale it down uniformly because when we lose the thickness, or we change the thickness rather. So right here we have our secondary bracket. So now we have two brackets that are mounted to the frame that will cradle this. So this video is starting to run a little bit long, so I'm just going to speed up. If it's too quick, I'm sorry. I have to keep with some sort of time constraint. So I just rotated that a little bit as it comes down, and now I can move it to the side a little bit. Now where's our axis oriented to? So it looks like we can actually say our axis should be, it's positioned to the selected and rotated to the axis. That doesn't really do us much good. Normal? No. It just doesn't seem to be rotating it very well, so I'll just leave it at axis. And then we can, so now that we have this brought down, we can extrude again and sort of move it over to where it needs to be, like that. The cool part is that we can smooth that out later. So we have this face right here and this group of faces, and we can just also move it forward a little bit as it's being twisted, and using our same equal dimension rule, we can move this up till it's there, and then we extrude it by the same as its width. So we extrude it by 1/4 of an inch, and then we can pull it forward, and that's the bracket, or at least part of it. So we'd want to bevel that. I wonder what happens if we bevel both edges. How messy is this going to be? Not messy at all. It's actually a really good result. You need to clean up the edges here, but for now we can just select these edges and melt them. Rotating around the other side. select those edges and melt them. We do have doubling up of edges there that looks kind of weird, but that's okay. We can scale these down 70%. And we have a much better looking round. And so this is one bracket. We can really quickly make this look a lot better. Loop selection, bevel, nothing fancy. Loop selection, bevel, again, nothing fancy. And then we can select that edge up there and its neighboring edge. And we can use a subdivision of 2. And it actually looks like a bracket that's meant to be there. Does it get in the way of our steering? That's something I didn't test while we were creating it. And it looks like it does not. Lovely. Well, it technically does up here, but we can fix that by pushing it back against the edge of the piece of the frame it's supposed to be against. So we can actually just select this stuff right here and push it back, rotate it a little bit. And it gracefully gets out of the way. So yeah, that looks pretty good. We can just slap some bolts on that and it'll look, I hope it'll look pretty official. We can also get rid of these sharp edges here. It just makes it more convincing. In engineering, they often try to get rid of the sharp edges, I guess. So we can just round that off a little bit, makes it look more like a bracket. Now we have this secondary bracket up here that we created, and it would be really cool if this could also come down and sort of create that reinforcing look that we're going for. So what we can maybe do is just bring it down around the edge and have it just grab on the outside. So it's going to be a bit of a long shot, but let's try it either way. So I'm just going to extrude, and then at this point I'm just moving this around in space, very freeform like. All the rules are gone at this point. So I'm just gonna go from the side view now, and I'm gonna just bring it all the way down. So the next step would be to line this up. I'm trying to get this axis handle to, right, well, that's good. It points at the normal. So there's really no accuracy in what I'm doing at this point. I'm just trying to make it look okay. And now we can extrude out, and if we extrude, we keep the normal, which means we can then select the block we just extruded and rotate it like that. Now we can, let's switch to the axis again. It's not going to benefit us much, but now we can start to, now that we have this solid shape, we can start to reshape it. For instance, now that we have this face selected, we can switch to the normal move mode, and we can move it down along its normal. So it gives us that. We can go back to normal moves, recent tools menu that I don't use enough. And so we can sort of have that bracket mount right there. And then we can start to slide edges around. So we can slide this edge here up. We can do something similar with this edge right here. And we can start to move things around. Now with the edge mode, if we use the axis selection, it's going to orient itself to the edge, so we can actually pull the edge in like that. And this is starting to look really robust, which is good. I like that. And so we can now select a loop and bevel it. I'm just going to use 0 subdivisions because I just want this to be a rough shape for now. And I can use the Kayama slide plugin to slide the edges along, the groups of edges. So the regular Cinema 4D edge tool to my knowledge, does not actually allow you to slide a group of edges, but the Kayama Slide plugin does. Hope I'm pronouncing that right. And so we can just sort of, we're just organically creating this bracket, almost as if a you know, an engineer or technician is just bending a piece of steel to make it fit, and then once he knows how it fits, he can plug it into the CNC machine and actually have it make them. But at this point, we don't know what they're supposed to look like. So again, we're still running kind of long on time. I didn't forget about that, so I'm trying to make this a decent length. I'm just trying to move it along. And so I'm just going to select this edge and that edge, and we do our bevel here with one edge. I think that looks good. And we can do one up top here as well, because this is sort of an exposed sharp edge, and us humans don't like that. And so we can then bolt that on. And, you know, we can select some of these loops of edges and make them smoother if we wanted to. But right now I don't want to. I think it's fine like that. Maybe just this one in the middle. And to evenly space out our geometry, we can use the slide tool to make these edges look a little bit more radial and natural. And I think that's it for now. So we have these, well, we need to mirror those brackets. So we can now select these two brackets, and we can group them and call them Hazcam Brackets. And we have a cube here, which should also be a Hazcam bracket. And we can then select this Hazcam Brackets group, put it into the well, what we could do is, this is sort of symmetry. These won't move and they're fixed to the frame. So let's see. We have a symmetry object here that contains the LiDAR instance. Let's just create another symmetry object just for these Hazcam brackets. So what we can do is create a symmetry object with no special modifier. Cinema 4D just puts it at the root, and we can move it up to around where the brackets are, still centered. And then we just put our Hazcam brackets into the symmetry, and they mirror to the other side quite nicely. So we can call this now Hazcam Symmetry, Hazcam Bracket Symmetry. And we can move this down to where the instruments are. So now we have Hazcam Null, Null Instance, Brackets, Symmetry. So the brackets are going to be symmetrical. Anything we do to one will be done to the other. And in addition, we still have full freedom of rotation of our Hazcams. And, you know, this is just sort of rounding off the instrumentation at the front of the machine a little bit more. Because now that we have more of the instrumentation in the front profile, we can start to create the body armor and see how that looks, how that feels. So in the next episode, we might add some nuts and bolts to the Hazcam, or we might not. We might just jump into creating the body armor. But that's the direction I'd like to go in. So until next time, see ya.